Hello and welcome to your lesson on changes in climate. And we're going to look at climate change in this lesson as a look through time. We're going to focus on historical climate change for the majority of this lesson. And then in your follow-up, you will look at some of the modern causes of climate change and human-caused climate change. So it's been around a while. Scientists have been warning us about climate change since the 90s. So climate is different than just weather. So right now it might be sunny outside and pretty hot, and climate is actually the average weather conditions in an area over a long period of time. So just because we have a really cold winter or a really warm winter or lots of snow one winter or not so much snow one winter or a hot summer or a dry summer, that doesn't make it the climate. The climate is many years of data compiled together. So we're looking at average weather over long periods of time. So you can't take a big storm or a single season to represent the climate. So ice ages have been part of Earth's history. So geologic records tell us that Earth's climate has been much colder than today. And typically it's much colder than it has been today, or is today as far as climate. So ice ages are a period in which ice collects in high latitudes and moves towards the lower latitudes. This is when a massive, like the last one, a massive ice sheet came from Canada or covered Canada and made its way into the northern US. And the most recent ice age began about 2 million years ago and ended about 10,000 years ago. Here is what that ice sheet would look like covering the northern part of our globe, parts of the Himalayas, and Antarctica. And if you notice, the ice age absorbs water, or not absorbs, but water is frozen in the ice, so there's less water in the oceans, and so the shape of our continents change a little bit during ice ages as well. So ice ages are separated into glacial periods and interglacial periods. The glacial period is during an ice age when these sheets of ice are advancing, and because large amounts of water is frozen, the sea level drops. In the interglacial periods, the ice melts and sea level rises. So, like I said, 10,000 years ago, we started our latest interglacial period. So, causes of the ice ages. So there's a couple theories because we're not 100% sure of the exact causes yet, but the leading theories are the Milankovitch theory, that ice ages are caused by changes in the Earth's orbit and the tilt of the Earth on its axis combined. So Earth's orbit changes in about 100,000 year period between elliptical, meaning kind of looking like an oval or an ellipse, to more circular. And then in a 41,000 year period, the tilt of the Earth axis varies between 22.2 degrees and 24.5 degrees. And so these two events combine at different times to change the Earth. So here's what that looks like. The purple line on here represents the elliptical orbit. So at some points we are closer to the sun and some points we're farther away, where the red line shows a circular orbit where we're more uniformly distant from the sun. And as we get closer and farther from the sun, that will change the amount of solar energy the Earth gets. And then when the tilt of the Earth changes, it makes it so that the poles receive more or less energy depending on how much it's tilted. So the more tilt we have, the more energy the North and South Pole get, and the less tilt we have, the less energy they get. And then this is all combined into precession, which is the wobble in the orientation of the Earth's axis and where we are in our path around the sun. Another theory about what causes ice ages is partly due to plate tectonics. And this states that ice ages happen when the continents have moved closer to the polar regions. So 250 million years ago, Pangaea was a supercontinent near the South Pole, and during this time there was an ice age. And as it broke apart, the continents moved towards the equator and the ice age ended. And during the last ice age, Antarctica and northern North America, Europe, and Asia were closer to polar zones, and that caused them to be covered in large sheets of ice. Don't forget, the plates are constantly moving at a rate about how fast your fingernails grow. So we're thinking in terms of geologic time, and so with it being in geologic time, that means the continents are moving and can change the climate. Another contributor is volcanic eruptions. Volcanic eruptions, especially large ones, send enormous amounts of dust, ash, and smoke into the atmosphere. And once they're in the atmosphere, these particles act like a shield, cooling the Earth by blocking sunlight. So here you can see kind of the yearly flux in temperature. And right after the volcanic eruption in year 0, we get a quick drop for several years of surface temperature on the Earth. And albedo is just how much light is reflected back into the atmosphere, into space from the Earth. So asteroid impacts also affect climate. Large pieces of rock slam into Earth. If it's big enough, it's like a volcanic eruption. It shoots dust and debris into the atmosphere that blocks sunlight and thermal energy. So 65 million years ago, a 10-kilometer diameter, that's about a 6-mile in diameter asteroid hit Earth and caused a change to Earth's climate and a mass extinction. And adding to this also is the sun cycle. The sun has an 11-year cycle of changing from solar maximum to minimum in terms of how much high energy radiation is produced by the sun. So changes in radiation affect the winds in the atmosphere, which changes how climate and weather moves around the world. So here's a look at that 11-year cycle. And this is just measured in this graph based on sunspot numbers and predictions, and it's pretty much been really close to the predicted range over time. So historic climate change is complicated. That's why we don't have a 100% definitive answer, but we have several theories and things that have contributed to climate change, and because it's really complicated, they have to put all that together to figure it out. So this is a look at the average temperature on Earth for the last 140 years. As you can see, we are not just talking about climate change, but right now we are talking about global warming. And so this is 4 different research centers data, but all of them would agree that our climate is changing into a warmer climate. And then this is a look at carbon dioxide historically for the last 800,000 years. And when it's higher, we get more of a when it's higher, we get the interglacial period, and when it's lower, we get an ice age, because this will correspond with temperature. So the highest previous concentration came about 330 million years ago. And then now we are at 407.4 parts per million of carbon dioxide in our atmosphere. So we are far above the previous highest concentration that we have discovered through our research. And so that does not bode well for the Earth, because modern global warming is driven by the greenhouse effect. So the greenhouse effect is the warming of the surface and lower atmosphere of Earth that occurs when water vapor, carbon dioxide, and other gases absorb and re-radiate thermal energy. Carbon dioxide being one of the major ones, methane and sulfur dioxide also play a role, but carbon dioxide is one of the main players in this greenhouse effect that humans can control. So this is a visual of what that kind of looks like. So sun's energy comes into Earth, and sunlight hits the Earth and is reflected, and some comes in and becomes heat. So when we were talking about volcanic eruptions and asteroid impacts, it increases that reflected sunlight before it even comes to the surface of the Earth. But now we're talking about global warming and carbon dioxide and other gases in the atmosphere trapping heat and keeping the Earth warm. So, things we are doing to increase the greenhouse effect. We are burning fossil fuels, whether that's for energy production, transportation. Anytime that we're burning fossil fuels, we are releasing carbon and carbon dioxide into the atmosphere, which increases the greenhouse effect. When we clear forests and burn them, remember carbon is a major component of life on Earth. And so when we clear forests, we are releasing that carbon, and part of that's in the form of carbon dioxide into the atmosphere, especially when we burn them. And you may be wondering, why are we clearing forests? We are clearing forests for more places for people to live, more places to produce agriculture, for resource extraction. So we're clearing forests for a variety of reasons. Some places they're clearing forests for fuel to burn to cook. And then with less forests, we get less carbon dioxide removed from the air. So it's kind of a double whammy. Not only did we increase the amount of carbon dioxide in the air, now we have less ways of taking it out. So some consequences of global warming. Ice caps will start to melt. When ice caps melt, ocean levels start to rise. Ocean levels will become more acidic with global warming, and many people that live along oceanic coasts will be displaced. That means they're going to have to find someplace new to live. They're going to have to build up things along the coast to help protect them. So it's going to lead to people needing to move farther inland. Weather patterns are going to change. And with that's going to come more frequent and severe weather. So bigger storms that are going to happen more often. I was reading an article about Venice, that Venice will flood more often as sea level rises and as the storms start to change. That's just an example, but we might see more hurricanes during hurricane season, more tornadoes, things like that. Species will start to go extinct if they can't move or adapt. So as the temperature of our Earth rises, certain things that species need to survive will change, and if they can't adapt to that or move to a place where they have those conditions they need, they will go extinct. Agriculture will have to change. What we grow and where we grow it may start to change as weather patterns change, as the heat and how hot the Earth is changes. Some places may become too dry to grow certain crops. And air pollution will get worse. So in Salt Lake, you're probably used to the summer air pollution with ozone. Part of that is caused through heat. And as the Earth warms up, we're going to increase the ground level ozone. And so air pollution, especially in the summers in Salt Lake, will start to get worse. So those are some consequences of global warming. So climate change has been happening for as long as Earth has been around. But now what we have is human-caused global warming. And a lot of it is due to greenhouse gases that we are producing, and we have been producing since the start of the Industrial Revolution and before, and that we are now producing in even larger quantities and making it so that our Earth is getting warmer and will continue to get warmer. And so we need to start working on ways to minimize the amount of carbon dioxide we produce as a human population.